Hello everyone, my name is Sheikh Mohammed Kashif. Today I'm going to talk about information retrieval in search engines. Let's talk about information retrieval in search engine. This is like the beginning of our journey, like the opening scene of the movie. In our case, we are going to explore search engines. But what are search engines? Think of them as the helpful tool that finds things for you on the internet. They are like the digital wizards that quickly find what you're looking for. You use them when you're searching for information or shopping online. Search engines have become a big part of our digital life. So our journey begins with understanding how search engine works and why they are so important. Now, let's talk about what is information retrieval. It might sound a bit technical, but it's not that complicated. Information retrieval is like a digital treasure hunt on the internet. When you type something into a search engine, it goes on a mission to find all the web pages, documents, or videos that match your words. It's all about finding the right information from the big sea of data out there. Think of it as the search engine's superpower. Gerard Salton, a smart person, called it the art of organizing, storing, and finding information. So, every time you search for a new recipe, check the latest news, or do school research, you are part of this exciting world of information retrieval. Moving to the next slide, what is search engine? This is where we get to the exciting stuff. A search engine is like a superhero librarian in the digital world. It's like your friendly librarian who takes your questions and goes to find the right books for you. But here's the magic. It's not just about finding the exact words you type, it's also look at the quality and popularity of stuff it finds. Search engines use secret formulas to decide which stuff should come first. You have probably heard of Google, right? It's one of the famous search engines, but there are others like Bing, Yahoo, and DuckDuckGo. So the next time you are searching for song lyrics, solving a puzzle, or checking out the latest fashion trends, remember that a search engine is working hard behind the scenes to get you the answers you need. Now, let's talk about the key things that make search engines work well, like the one you use to find information on the internet. Imagine a roadmap for building a good search engine, which is shown in figure. The first big issue is relevance, which means making sure the results you get are not just a bunch of stuff, but actually useful. This is where ranking comes in. Search engines use special rules to put the most important results at the top, so you see the best stuff first. Next, there's evaluation. This is like checking to see if your search engine is doing a good job. We use tests and measures to see how well it's working. Then comes information needs, which is all about understanding what you want. The search engine tries to learn from you, the user, so it can show you the right things. It also uses tricks like suggesting better search terms or learning from what you click on. Another important thing is performance. This is about making search engines fast and making sure they can find things quickly. We also need to keep the information fresh and up to date. So that's incorporating new data. Scalability means the search engine should keep working as more people use it. And we have adaptability, which means it can be changed to fit different needs. Finally, there are specific problems like stopping spam for showing up in search result. They are all the important things that make search engines like Google work well. Now, my teammate Mansoor going to talk about goals of search engine.
Thank you, Kashif, for introducing me. In this slide, we'll be talking about two primary goals of search engine. Effectiveness. We want to be able to retrieve the most relevant set of documents possible from a query. And efficiency is that we want to process the query from the user as quickly as possible. To fulfill those two primary goals, search engine supports two major functionalities. First is indexing process and the second is query process. Indexing process builds the structure that enables searching, and query process uses those structures and the person's query to produce high ranked list of records. So let us get an overview of how indexing works. So whenever a user enters a query in the search bar and hits the search button, the respected web pages or websites are displayed on the web browser. But behind the scenes, there's a component called as a web crawler. The web crawler crawls to all the related websites to the query that was given by the user and makes and maintains an indexing and ad indexing of it. From these indices, the high ranked websites are then displayed to the user's web browser. So let us now see the flow of the indexing process. The emails, web page, news outlets which are available on the web are given to the first step called as text acquisition as input. From text acquisition, it goes to text transformation, then index creation. This is where the index is created. Now, the major three components in the indexing processes are text acquisition, text transformation, and text creation. Now, let us take a deeper look in the basic components of the indexing process. Text acquisition process. So firstly, whenever we receive the query from the user, the first step that we need to do is to find all the related websites to the respected query and make sure that all the websites are available for the searching. Now this entire thing is done by the text acquisition process. The first component of the text acquisition process is crawler or a web crawler. A web crawling is a process by which we gather the web pages from the web. The objective is to quickly and efficiently gather as many web pages as possible together with link structure that interconnects them. There is also another mechanism called as document feed, which is a mechanism for accessing real-time stream of documents. For example, if in news feeds we need a constant stream of new news and updates, which is done by the news feed, which basically does by monitoring the RSS square. Once the documents are found by the crawler and the news feed and the document feed, they are rarely in the plain text format. Instead, they are in the format. Instead, they might be in the format of HTML, XML, PDF, Word, PPT. But we need to make sure that we convert them in the plain text metadata format, which is done by the converter component. Finally, we have a document data storage, which is a database used to manage large number of documents and structured data that are associated with it. Text transformation is the next major component in the indexing process. Text transformation component transforms the documents into index terms and or feature terms. It also has subcomponents like parser. Parsing component is responsible for processing the sequence of text tokens into documents to recognize structural elements such as titles, figures, links, and headings. The next components are stopping and stemming. These are word level transformations. In stopping component, it simply removes the common words from stream of tokens. Whereas in stemming component, it groups the words that are derived from the common stem. For example, fish, fishes, and fishing. In extraction and analysis component, the links and anchor text in the web page are identified and are extracted during document parsing. By extraction, I mean that they are recorded in the document data storage and are indexed separately from the general text. Finally, we have a classifier component which identifies class related data from the document and labels them in categories. So the final component in the indexing process is index creation component, which basically creates indices and or data structures that enable fast searching. It also has subcomponents like weighting, which basically weighs the importance of words in the document, which is used for ranking the document. We also have inversion component, which basically changes the stream of document term information into term document information to create inverted indices. Finally, we have index distribution component, which distributes the indices across multiple computers and potentially across multiple sites on the network. Now my teammate Vikas will talk about query process in search engine.
Hi everyone, thank you for giving me opportunity to discuss on this very interesting topic which is query process. I am Vikas Kumar here. Welcome to the presentation on query processing in search engines. So in this short presentation, we will explore the critical steps involved in understanding and processing a user's query to retrieve relevant documents from a search engine index. So before that, we have the architecture of search engine. So we have user interaction, ranking, and evaluation. So you can see that user interaction organizes ranked documents for user presentation. Ranking generates ranked list of documents using retrieval model scores, and evaluation will analyze user behavior using log data. Let's start with the very first step, which is tokenization. So imagine it as the gateway to your search engine's treasure trove. Tokenization is all about breaking down your query into individual words or terms, making them more manageable. For example, we have this query best coffee shops. This query gets transformed into three distinct terms: best coffee and shops. It's like breaking a complex code into its individual components. Now let's move to the heart of improving search results, which is query expansion. It's like a toolbox for refining your queries. Query expansion includes techniques like synonym expansion, stemming, spelling correction, and the removal of stop words. So these are your tools for precision, helping you find the right information in the hashtag of the web. Our next topic is a deep dive into the query expansion techniques. These are your trusty sidekicks in the world of query processing. So in the synonym expansion, we expand your queries with related terms to cast a wider net. Stemming reduces words to their roots for more inclusive searches. Spelling correction fixes typos for pinpoint accuracy. Removal of stop words. It eliminates fluff words to zero in on the essentials. We are going to explore each of these heroes in detail. So the next thing we have is get ready to meet the future of search with query language models. These models are like your personal language interpreters that decipher your intent, especially in those tricky, ambiguous queries. It's like having a conversation with your search engine, and, and it ensures you get precisely what you are looking for. So next is time to build the power of Boolean operators, which your search engine's secret weapons. They allow you to construct queries with precision. For example, and refines your search results by requiring all terms, or broadens your search by allowing any term. Not lets you exclude specific terms to focus your results. These operators are your keys to customizing your search to perfection. We are not stopping there. Advanced query features elevate your search to a new level of precision. For example, we have phrase queries which search for extract phrases within quotes. Wildcard queries use wildcards for partial matching. Proximity operators specify term closeness for surgical precision. These features make you in the maestro of your search orchestra. Now let's talk about making your search more personal. So search engines consider your context, which is your location, your query history, and intent. It's like having a search engine that knows you inside out. This personalization transforms search results into a tailored experience, giving you exactly what you need. So before your queries hit the search engine's index, they go through essential pre-processing. Think of it as the spell check before the final draft. It involves removing punctuation, normalizing case, and addressing special characters. So these tasks ensure the precision and accuracy of your searches. So the conclusion is query processing is the initial step, breaking down queries into manageable units. While query expansion techniques, Boolean operators, and advanced features empower users to fine-tune their searches, and user context personalization and query pre-processing enhance the relevance and accuracy of results. This is it. Thank you so much.